Imagine a world where warm, lush forests cover the land we now call Antarctica. Picture an Earth where the towering Himalayas, the roof of the world, simply don't exist, and India remains snuggled near Africa. What if kangaroos and their relatives, instead of being unique to Australia, either roamed across a connected globe or were outcompeted into oblivion? Consider a Europe that isn't a distinct collection of peninsulas and islands, but just a flat, unremarkable western edge of a colossal landmass. And what if North America's familiar west coast, with its dramatic mountains and fault lines, was instead a calm, featureless plain? This isn't a far-fetched dream, it's a glimpse into the scientifically plausible reality of our planet if the ancient supercontinent Pangea had defied geology and never ever fractured. Continents we know today are merely fragments of this giant, and their modern identities are almost entirely thanks to that colossal breakup. Had it stayed whole, their fates, landscapes, and even life forms would be unrecognizably different. Number 6. Antarctica, the Great Green Southland. Today, Antarctica is a land of superlatives. Coldest, driest, windiest, and highest average elevation of all continents, almost entirely buried beneath a colossal ice sheet. Its very name conjures images of desolate beauty, emperor penguins, and heroic frostbitten explorers. But this icy persona is a relatively recent development in geological terms, a direct consequence of its isolation at the South Pole after Pangea's disintegration. If Pangea had remained intact, the landmass that would eventually be called Antarctica would have had a drastically different story. During the time Pangea existed, from the late Paleozoic to the early Mesozoic eras, roughly 335 to 175 million years ago, Antarctica was positioned much further north than it is today. It was a key part of Gondwana, the southern portion of Pangea, connected to what we now know as South America, Africa, India, and Australia. This connection, and more northerly latitude, meant one thing: warmth. Imagine Antarctica not as a polar wasteland, but as a vibrant, temperate, or even subtropical region. Without the circumpolar current, the ocean flow that thermally isolates Antarctica today, chilling it to its core, warm ocean waters from the vast Panthalassic Ocean, the superocean surrounding Pangea, would have lapped its shores. These currents would have brought heat and moisture, preventing the formation of the massive ice sheets that define it now. Fossil evidence from Antarctica already tells us this isn't pure fantasy. Coal deposits, fossilized forests of Glossopteris trees, and remains of dinosaurs like Cryolophosaurus and Lystrosaurus prove that it once hosted complex ecosystems in a much milder climate. Had Pangea persisted, these ecosystems would have continued to evolve. Instead of ice fields, picture sprawling forests stretching across much of the continent. Broad-leafed trees, ferns, and perhaps even early flowering plants would have thrived. Rivers, fed by ample rainfall rather than glacial melt, would have carved valleys. The transantarctic mountains, which today bisect the continent and were partly uplifted during the rifting processes associated with Pangea's breakup, might either not exist in their current prominent form or be a much older, more eroded range, perhaps part of the original seams where Gondwana's pieces join. The landscape would likely be far less dramatic in terms of sharp, icy peaks, and more characterized by rolling hills, plains, and forested uplands. Animal life would be unrecognizable compared to modern Antarctica. There would be no ice-adapted penguins or seals as we know them. Instead, diverse communities of reptiles, amphibians, early mammals, and countless insect species would inhabit its varied biomes. Large herbivores might have browsed the forests, preyed upon by carnivores, all part of a complex food web integrated with the rest of southern Pangea. Creatures found here would share common ancestry with those in adjacent parts of Pangea like Proto-Australia or Proto-Africa, rather than evolving in extreme isolation. concept of a polar desert would be alien to this Antarctica. Its coastlines, part of the larger Pangean shore, would host diverse marine ecosystems, perhaps with coral reefs in warmer, shallower areas and teeming with fish and marine reptiles, vastly different from the specialized cold water species of today. The very idea of an Antarctic treaty or scientific basis focused on glaciology would be absurd. It might instead be a populated land rich in biological diversity and perhaps even ancient Pangean human settlements, had humans evolved on such a world. Its resources wouldn't be locked under miles of ice. Vast coal seams, remnants of its ancient forests, would be far more accessible, potentially fueling the industries of this alternate Earth. Antarctica in a Pangea-never-broke world would be less a symbol of icy desolation and more a testament to a continuously warm, green, and interconnected southern land. Number 5. Australia. Just another connected province. Australia, the island continent, the land down under, is famed for its extraordinary and often bizarre wildlife: kangaroos, koalas, platypuses, wombats, a living museum of marsupial evolution. Its landscapes are equally iconic, from the sunburnt deserts of the outback and the vibrant Great Barrier Reef to its unique eucalyptus forests. This distinctiveness is overwhelmingly a product of its long geological isolation, a continental raft that broke away from Antarctica around 45 million years ago and drifted northwards, allowing its flora and fauna to evolve on a separate, unique trajectory. But rewind to a Pangea that never sundered, and Australia's story morphs from one of splendid isolation to one of enduring connection. Within the supercontinent, the landmass that forms modern Australia was wedged between Antarctica, India, and possibly parts of Southeast Asia. It was not an island, but an integral part of eastern Gondwana. The most dramatic alteration would be to its biology. The iconic marsupials, which thrive in Australia today largely because they faced little competition from placental mammals for millions of years, would have faced a very different evolutionary battlefield. Placental mammals, which originated elsewhere on Pangea, would have had free rein to migrate into the Australian portion of the supercontinent. In this scenario, marsupials, if they arose as a group, might have been outcompetted early on by these more adaptable placentals, perhaps relegated to small specialized niches, or even driven to extinction across most of Pangea, including the Australian sector. The familiar sight of kangaroos bounding across the plains or koalas munching eucalyptus might simply never have come to be. Instead, the animal life of this Pangean Australia would likely mirror that of adjacent connected regions, a mix of widespread Pangean creatures, perhaps early dinosaurs evolving into new forms, synapsids, mammal ancestors, and other groups that dominated the Triassic and Jurassic period. There would be no evolutionary impetus for the unique adaptations seen in modern Australian fauna, like the platypus's bill or the echidna's spines, which arose in response to specific isolated environmental pressures. The climate and landscape would also be vastly different. While Australia today has vast deserts, its Pangean counterpart, nestled within a larger landmass, would experience climate patterns dictated by the supercontinent's overall atmospheric circulation. The Great Dividing Range, a coastal mountain chain crucial to eastern Australia's rainfall, was uplifted relatively recently, partly due to stresses from the opening of the Tasman Sea. In a stable Pangea, this range might be absent or far less significant. This, combined with its interior Pangean location, could mean that the deserts of this Proto-Australia might be even more extensive and severe part of the vast arid heart that characterized much of central Pangea. Coastal regions might be more humid, influenced by the Panthalassoc Ocean or the Tethys Sea. But the character of these coasts would be different. No Great Barrier Reef, for instance, as its formation is tied to specific sea levels, temperatures, and Australia's northward drift into tropical waters. Geologically, the Australian landmass would lack the unique features carved by its independent journey. Its mineral wealth, often concentrated by processes related to its tectonic movements and volcanic activity, post-breakup, might be distributed differently or remain undiscovered. Culturally, if humans had evolved on this Pangean Earth, the region we call Australia would not be a distinct continent with its own indigenous cultures developed over tens of thousands of years of isolation. It would be just another territory within a larger Pangean civilization or collection of interconnected cultures, its history inextricably linked to its neighbors. The tyranny of distance that shaped modern Australia's development would be non-existent. It would simply be a province of Pangea, its fate tied to the geological and climatic stability of the entire supercontinent. Number 4. South America, the continent without its mountainous spine. Modern South America is a continent of dramatic contrasts. The colossal Andes mountain range running like a spine down its western flank, the vast, humid Amazon rainforest, the sprawling grasslands of the Pampas, and the arid Atacama Desert. Much of this geographical character and the unique biodiversity it supports is a direct result of tectonic forces that came into play after Pangea began to break apart, and as the South American plate drifted westwards. If Pangea had remained a single, solid landmass, South America's geography would be profoundly altered. The most significant absence would be the Andes. This mighty mountain range, home to some of the world's highest peaks outside of Asia, was formed by the subduction of the Nazca Plate and its predecessors beneath the westward moving South American Plate. This process began in earnest during the Mesozoic and Cenozoic eras, long after Pangea's theoretical time of persistence. Without this westward drift and subduction, the Andes simply would not exist. Imagine Western South America not as a towering wall of mountains, but perhaps as a relatively flat coastal plain or a region of older, much more eroded highlands, similar to the ancient shields found in eastern South America or Africa. The absence of the Andes would have monumental consequences for the continent's climate and hydrology. The Andes act as a massive barrier to atmospheric circulation, forcing moist air from the Atlantic and Amazon basin upwards, causing it to cool and release its moisture as rain on the eastern slopes. They also create a strong rain-shadow effect to their west, contributing to the extreme aridity of the Atacama Desert, one of the driest places on Earth. Without the Andes, wind and moisture patterns would be completely different. Rainfall might be more evenly distributed across the continent, or different regions might become arid. The Atacama might be a fertile plain. The Amazon basin, while still likely a vast river system due to the continent's equatorial position and the shape of its ancient cratons, would have a different climate regime. Its size, vegetation type, and the course of the Amazon River itself, which once flowed westward before the Andes rose, would be drastically altered. Many of its tributary rivers, which originate in the Andes, would not exist or would have different sources and paths. Biologically, a Pangean South America would have a fauna and flora deeply interconnected with that of Africa, to which it was directly joined in Pangea. The distinct evolutionary paths that led to South America's unique animals such as New World monkeys, sloths, armadillos, and a dazzling array of bird species were often shaped by periods of isolation followed by events like the Great American Biotic Interchange, when North and South America reconnected. In a persistent Pangea, there would be a continuous, long-term exchange of species with Africa and other connected parts of the supercontinent. This could mean that many of South America's signature creatures might never have evolved their unique traits, or they might be found across a much wider Pangean distribution. The incredible biodiversity hotspots associated with the varied elevations of the Andes would be absent. Furthermore, South America's volcanic activity and earthquake zones concentrated along the Andean chain would largely disappear, as these are direct products of the active subduction zone. This would mean fewer geological hazards, but also a different distribution of mineral resources, as many ore deposits are formed by magmatic and hydrothermal processes associated with mountain building and volcanism. The western coastline itself would be a passive margin, like the eastern coasts of North and South America today, rather than an active convergent boundary. This means fewer deep sea trenches offshore and a gentler transition from land to ocean deep. Essentially, the South America of a Pangea that never was would be a shadow of its current self, flatter, with a fundamentally different climate system and a biota that spoke more of ancient Pangean unity than of unique continental evolution. Number 3. Europe, the unremarkable western promontory. Europe, as we conceive of it today, is a continent of intricate coastlines, peninsulas, islands, and a complex tapestry of mountain ranges like the Alps, Pyrenees, Carpathians, and Apennines. Its history is one of distinct cultures, developing in varied landscapes, often separated by these natural barriers. However, much of Europe's defining modern geography is a result of tectonic collisions and adjustments that occurred after the initial breakup of Pangea. If Pangea had never fractured, the landmass we call Europe would likely be almost unrecognizable, perhaps not even warranting a distinct continental name. It would exist as the westernmost part of Laurasia, the northern superblock of Pangea, back and connected to North America, to its west, before the Atlantic rifted, and Asia to its east. Its southern edge would have been defined by the Tethys Sea, a vast ocean that separated Laurasia from Gondwana. The most striking geological difference would be the absence of its iconic alpine mountain system. The Alps, along with the Pyrenees, Carpathians, and other ranges in southern Europe, were primarily formed by the northward collision of the African and smaller Adriatic-Iberian plates with the Eurasian plate. This complex series of collisions, which began in the Cretaceous period and continues today, crumpled the Earth's crust to create these majestic peaks. In a world with an intact Pangea, Africa would have remained part of Gondwana, far to the south, and these collisions would never have happened. Southern Europe, instead of being mountainous, might be a relatively low-lying plain or a region of ancient, heavily eroded highlands, perhaps remnants of the Variscan orogeny that occurred during Pangea's assembly. The Mediterranean Sea, a defining feature of southern Europe's climate and history, would not exist in its current form. The Mediterranean is a remnant of the western Tethys Ocean, which became progressively squeezed and partially closed as Africa rotated and pushed northwards. Without this African movement, the Tethys might have remained a wider, open seaway, or perhaps a different kind of inland sea would have formed due to other Pangean dynamics. But the familiar basin surrounded by young mountains would be absent. This means no Italian peninsula as we know it, no Greek archipelago born from tectonic complexity, and a completely different southern coastline for the Eurasian landmass. Britain and Ireland, today separated from mainland Europe by the English Channel and the Irish Sea, shallow seas that were dry land during recent ice ages, would be firmly welded to the western Pangean landmass. Scandinavia, while it might still experience glaciation during ice ages, if they occurred in this alternate world, creating fjords would also be an integral part of this larger continent, not a distinct peninsula shaped by the opening of the North Atlantic. The climate of this Pangean Europe would be drastically different. The moderating influence of the Atlantic Ocean and the Gulf Stream would be absent or vastly altered. Regions that now enjoy temperate maritime climates, like Western Europe, could experience more extreme continental climates, hotter summers and colder winters similar to interiors of large landmasses today. Southern Europe, without the Mediterranean Sea and Alpine barrier, would have a climate shaped by its proximity to the Tethys and the vast Pangean interior to its east. Possibly arid or semi-arid in places. The familiar wine regions of France, Italy, and Spain might be barren plains or windswept steppes. Biologically, there would be no isolated European biomes. Flora and fauna would be part of a continuum stretching across Laurasia. Species migration would be unimpeded by major mountain barriers, or seaways. Distinct European species that evolved in response to later geographical isolation or unique alpine environments simply wouldn't exist. Culturally, the very concept of Europe as a cradle of distinct civilizations, shaped by its peninsular geography and internal mountain divides, would be void. It would be an undifferentiated part of a Pangean superculture or a series of cultures that spanned vast connected territories, its history woven into the broader narrative of Laurasia. Number 2. Asia, the land without its Himalayan crown. Asia, the world's largest and most populous continent, boasts an incredible diversity of landscapes. From the frozen tundra of Siberia to the tropical rainforests of Southeast Asia and the vast deserts of the Middle East and Central Asia. But its most defining and awe-inspiring geographical feature is undoubtedly the Himalayan mountain range and the massive Tibetan plateau that stands behind it. This colossal uplift is not just a scenic wonder. It profoundly influences Asia's climate, hydrology, and even its biodiversity. However, this entire Himalayan-Tibetan complex is a relatively young geological feature, born from a continental collision that would not have occurred if Pangaea had remained whole. The Himalayas were formed by the dramatic impact of the Indian subcontinent crashing into the Eurasian plate. Before this collision, which began around 50 million years ago, India was an island continent that had broken away from Gondwana, the southern part of Pangaea, and drifted northwards across the Tethys Ocean. If Pangea never broke apart, India would have remained nestled somewhere near Africa, Antarctica, and Australia as part of Gondwana. It would never have embarked on its solitary journey north, and therefore the monumental collision that raised the Himalayas and the Tibetan Plateau would never have happened. Imagine an Asia without this skyscraping barrier. The southern edge of the Eurasian landmass, where the Himalayas now stand, would instead likely be a coastal plain or a region of older, lower mountains, facing the Tethys Ocean or whatever body of water lay between Laurasia and Gondwana. In this persistent Pangean world, the Tibetan Plateau, the roof of the world, which covers an area roughly the size of Western Europe and has an average elevation of over 4,500 meters, would simply not exist. This region would be vastly lower in elevation, fundamentally altering the topography of a huge swath of Asia. The climatic consequences would be staggering. The Himalayas play a crucial role in the Asian monsoon system. Their massive height forces the moist summer monsoon winds from the Indian Ocean upwards, causing heavy rainfall over the Indian subcontinent and Southeast Asia. They also act as a barrier, preventing cold winter air from Siberia from sweeping southwards into India. Without the Himalayas, the monsoon dynamics would be entirely different. Rainfall patterns across South Asia, Southeast Asia, and even East Asia would be radically altered. Regions that are currently fertile and densely populated due to monsoon rains might be arid or semi-arid. Conversely, areas currently in the Himalayan range shadow, like parts of Central Asia, might receive more moisture. The vast deserts of Central Asia, like the Taklamakan and Gobi, might be different in extent and character, as their aridity is partly influenced by the distant range shadowing effect of the Himalayas and the Tibetan Plateau. Hydrologically, the impact would be equally profound. Many of Asia's largest and most important rivers, including the Indus, Ganges, Brahmaputra, Salween, Mekong, Yangtze, and Yellow River, have their sources in the Himalayas or the Tibetan Plateau. These rivers support hundreds of millions of people. Without these high-altitude sources of snowmelt and glacial meltwater, the flow regimes of these rivers would be completely different. Some might not exist at all, or they would be much smaller, fed only by rainfall in lower-lying areas. This would reshape agriculture, ecosystems, and human settlement patterns across much of Asia. Biologically, the Himalayas and Tibetan Plateau create a vast range of habitats, from subtropical forests at their base to alpine meadows and cold deserts at high altitudes, fostering credible biodiversity. They also act as a significant barrier to species migration between the Indian subcontinent and the rest of Asia. In a Pangea-that-never-broke scenario with no such barrier, the flora and fauna of the Indian region, still part of Gondwana, and the Eurasian region, Laurasia, would have evolved along different lines or with more ancient, shared Pangean ancestry, rather than undergoing the mixing and unique evolutionary pressures seen after India's collision. The distinct ecosystems of the high mountains would be absent. Asia, while still vast, would lack its most dramatic vertical dimension, leading to a continent with a fundamentally different climate system and a reshaped distribution of life. Number 1. North America, a west coast devoid of drama. North America, a continent of immense geographical diversity, is characterized by features like the Great Plains, the ancient Appalachian Mountains in the east, and most strikingly, the vast Cordilleran mountain system that dominates its western third. This western region, encompassing the Rocky Mountains, the Sierra Nevada, the Coast Mountains, and various intermontane basins and plateaus, is a landscape forged by intense tectonic activity that largely post-dates the breakup of Pangea. The famous San Andreas Fault, a testament to ongoing plate movements, is part of this dynamic western margin. Pangea had never begun to rift apart, and its constituent plates had not started their independent journeys. The North American landmass we know would present a dramatically different western face. During Pangea's existence, North America was sutured to Europe and northwestern Africa as part of Laurasia. Its western edge faced the vast Panthalasic Ocean. This edge was likely a passive continental margin, similar to the east coast of North America today, a relatively stable region without major mountain-building activity, subduction zones, or large-scale faulting. The entire western Cordillera, from Alaska down to Mexico, simply would not exist in its current form. The Rocky Mountains, for example, were primarily uplifted during the Laramide orogeny from about 80 to 55 million years ago due to shallow-angle subduction of oceanic plates beneath the westward-moving North American plate. The Sierra Nevada is a massive granitic batholith, uplifted and tilted, and the coast ranges are formed by accretion of terranes and ongoing subduction processes. All these mountain-building events are consequences of Pangea's disintegration and the subsequent opening of the Atlantic Ocean, which propelled North America westwards over the Pacific oceanic crust. Without this westward drift and the associated tectonic collisions and subduction, the western third of North America might be a broad, relatively flat coastal plain, or perhaps a region of ancient eroded hills, sloping gently towards the Panthalasic Ocean. There would be no dramatic peaks like Mount Rainier or Denali, no deep canyons carved by rivers descending from high mountains, like the Grand Canyon, whose formation is linked to regional uplift. The San Andreas Fault System, a transform boundary between the Pacific Plate and the North American Plate, would not exist, meaning California would be spared its frequent earthquakes, but also its characteristic coastal mountain ranges. The climatic implications of a flat west would be profound. The western mountains are crucial in controlling precipitation patterns across the continent. They force moist air from the Pacific Ocean upwards, causing it to cool and drop its moisture on the windward, western slopes, while creating extensive rain shadows to their east. This is why regions like the Great Basin, Nevada, Utah, are deserts, and why the Great Plains are relatively dry. Without these mountain barriers, Pacific moisture could penetrate much further inland. The Great Plains might be wetter and support different vegetation, perhaps forests instead of grasslands. The deserts of the American Southwest might be smaller or have different characteristics. The western interior, seaway, a vast inland sea that split North America in two during the mid to late Cretaceous period, was related to high global sea levels and tectonic subsidence in the continent's interior. In a stable Pangea, the conditions for such a seaway might not arise, or it would have a different configuration, profoundly affecting sediment deposition and the distribution of fossil fuels. Biologically, the diverse habitats created by the western mountains, alpine tundra, montane forests, high deserts would be absent. This would mean a lower overall biodiversity for the continent. Species distribution would also be different, as these mountains act as corridors or barriers for animal and plant migration. Canonically, many of the rich mineral deposits of western North America, gold, silver, copper, are concentrated by geological processes associated with mountain building, volcanism, and tectonic plate boundaries. Their formation and distribution would be entirely different. North America, in this Pangean scenario, would be a continent blunted on its western edge, its familiar dramatic landscapes replaced by a more subdued and geologically quiescent coastline, leading to a cascade of changes in its climate, ecosystems, and resource endowment. Its story would be one of ancient connections, not of a westward pioneering journey across a rugged, newly formed frontier.